Hello, my name is Jim Gerber, and I'm the Advanced Placement Calculus teacher at the American School Foundation of Monterrey in Monterrey, Mexico. This is the second in a series of video lectures that I'll be giving on polar coordinates and polar curves. In the first lecture, we talked about what polar coordinates are and how to plot points on a polar coordinate system. In this lecture, we're going to talk about converting from Cartesian coordinates to polar coordinates and vice versa. So just as a quick review, you'll remember in the last class we said that to plot a point on a Cartesian plane, the coordinate would be x comma y, and we move x units in the horizontal direction and y units in the vertical direction. In a polar coordinate system, the coordinate is given by r comma theta, in which we rotate through an angle of theta from the positive x-axis and then move a distance of r units from the pole. And so to convert between the coordinate systems, what we really need to do is we need to think about that diagram we had in the last class. So we're going to start by going from polar to Cartesian, which I think is a little bit easier. And if you remember the diagram we had, it looked something like this. And we said that to get to this point, we could do it two ways. We could say, start at the origin, go x units to the right, and then move up y units, and that would give us the coordinate x comma y. Or we could say, go to the positive x-axis and rotate through an angle theta, and then move a distance r along that angle, and that would give us the polar coordinate r comma theta. So this red dot on the end of this is actually in both coordinate systems now. This is the point x comma y in Cartesian coordinates, and the point r comma theta in polar coordinates. And so this diagram gives us all that we need to do the conversion. In order to convert from polar to Cartesian, what we're doing is basically saying, if we know what r and theta is, how do we get x and y? And we can see that x and y are connected to r and theta through trigonometry. In other words, if I take this x, this is the adjacent side of this triangle, which is right angled, and the adjacent divided by the hypotenuse gives us the cosine of the angle theta. And so we see that x over r is equal to cosine theta, and that leads us to a very easy way of finding the x-coordinate. If we're given r and theta, then if I multiply both sides of this equation by r, I'm left with x equals r times cosine theta. So if I know what r and theta are, I now have an easy way of getting x. I get y almost the same way. Y would be the opposite side of this triangle, and opposite divided by hypotenuse is, of course, the sine of the angle. And so I see that y divided by r equals the sine of theta. And now by multiplying both sides by r, again, I'm left with y equals r sine theta. And so it's very easy to convert from polar to Cartesian. If I know what r and theta are, then I can get x and y simply by saying that x is r times the cosine of theta, and y is r times the sine of theta, and that gives me my two Cartesian coordinates. Going from Cartesian to polar is almost just as easy. What we need to do in this case is we have to say, what do we do if we know what x and y are and we want to get r and theta? Well, getting r given x and y is very easy because this is a right angle triangle, and so we can just use Pythagoras. And we see that, of course, x squared plus y squared is equal to r squared, and therefore r is the square root of x squared plus y squared. To get the angle theta, we use one of the trig ratios again. In this case, the trig ratio that connects theta with x and y is tangent. We know that the tangent of theta is y over x, and so therefore theta is the inverse tangent of y over x. And now again, we have everything that we want. If we're given x and y, we can get r by taking the square root of x squared plus y squared. And if we're given x and y, then we can get theta by taking the inverse tangent of y over x. Let's look at an example. So in this example, we're given two things to do. First, we're asked to take the polar coordinate negative 4 comma 2 pi over 3 and convert that into Cartesian coordinates. And then in the second part, we're asked to take the Cartesian coordinate negative 1 and convert that into polar coordinates. To get an idea of what we're dealing with here, let's start by looking at the graph. If I was to graph, to plot the point negative 4 comma 2 pi over 3, what would I do? Well, I would move through an angle of 2 pi over 3 radians. Pi over 3 is 60, so 2 pi over 3 is 120 degrees, so that's going to put us in the second quadrant. And then I would go 4 units away from the pole But I remember that this is -4, so it's going to fold it back 180 degrees. And so my diagram is going to look something like this. I'm going to rotate through 2 pi over 3. I'm going to go up 4, but then I'm going to fold it to the other side. And so this is my point, -4, comma 2 pi over 3. And what I want to know is, what is this in Cartesian coordinates? I can see it's in the 4th quadrant, so it's going to be positive something, negative something. But I want to know what these coordinates would be. So what do? Well, I follow the process that we just outlined up here. To get x, I take r cosine theta. To get y, I take r sine theta. In this case, r is 4. And so to get x, r is actually -4. So I take -4 times the cosine of 2 pi over 3 radians, which is -4 times -1/2, which is 2. So my x coordinate is 2. And looking over here, yeah, that looks reasonable. And maybe I go over 2. My y coordinate is going to be r sine theta. So that's going to be -4 times the sine of 2 pi over 3. The sine of 2 pi over 3 is positive root 3 over 2. And so -4 times radical 3 over 2 gives me -2 root 3. So what I'm saying is that this polar coordinate, -4, comma 2 pi over 3, is equivalent to the Cartesian coordinate over 2 and down to root 3. So the Cartesian coordinate is 2, comma -2 root 3. In part B, we're asked to find the point -1, comma -1, and put that into polar coordinates. So -1, comma -1, of course, is over here in the 3rd quadrant. And all I need to put it in polar coordinates is r and theta. Well, r, we talked about up here. We said r is the square root of x squared plus y squared. So that's pretty easy. In this case, x is -1 and y is -1. So r is the square root of -1 squared plus -1 squared. In other words, r is the square root of 2. And what is my angle? Well, my angle is tangent inverse of y over x. So tangent inverse of -1 over -1, which is just tangent inverse of 1. But I have to be a little bit clever here. Remember, tangent inverse of 1 means that we're looking for the angle whose tangent is 1. And if we think of the graph of tangent, we recognize that that's a periodic function. And so there are actually an infinite number of angles whose tangent is 1. The first of those angles, what we call the principal angle, is pi over 4 radians. We know that the tangent of pi over 4 is 1. In other words, the tangent of 45 degrees is 1. But remember, tangent repeats every 180 degrees. So the answer could be 45, or it could be 225, or any number of whole number jumps of 180 degrees in either direction is going to give us a tangent of 1. We don't want pi over 4 because we know that -1, comma -1 is in the 3rd quadrant. So pi over 4, well, that would be in the 1st quadrant. That wouldn't make any sense. We want to be in the 3rd quadrant, so we have to add 180 degrees on that to get over to the 3rd quadrant. So in fact, instead of 45 degrees, we want 135 degrees, or in other words, 5 pi over 4 radians. So my polar point in this quadrant that connects to the point -1, comma -1 would be the point square root of 2, comma 5 pi over 4. In other words, I'm saying I imagine rotating through an angle of 5 pi over 4 radians, which puts me over here, and then going a distance of root 2, and that would give me my polar coordinate equivalent of -1, comma -1. Okay, so that's how we convert from coordinates, from polar coordinates to Cartesian coordinates, and from Cartesian coordinates back to polar coordinates. Now we want to think about converting equations instead of coordinates. So how do I convert an actual whole equation instead of just a coordinate? Well, it turns out we do pretty much exactly the same thing. So again, I'm going to give you 2 examples. The first one asks us to take this Cartesian equation, this sort of ugly, cubic, implicitly defined Cartesian equation, and convert it into polar coordinates. So in other words, we got to get rid of the x's and y's and turn it into r's and thetas. And in part B, we're asked to take this polar equation, r equals -8 cosine theta, and turn that into a Cartesian equation. Okay, one involving Cartesian coordinates. So the first equation is this, and all we do is the same thing we did before. We already said that we know that x equals r times the cosine of theta. So that's going to be r cos theta there. That's going to be r cos theta there. That's going to be r cos theta there. And we already said that y equals r sine theta. So we're going to have an r sine theta going into that. And my equation becomes this. I can clean it up a little bit. And I'm going to be left with 2r cos theta minus 5r cubed cosine cubed theta equals 1 plus r squared times cosine theta times sine theta. And that's a little bit messy looking, but it is in polar form now, so we've done everything that we were asked to do. In part B, we're asked to convert negative 8 cosine theta into Cartesian coordinates. Now, we could do the same thing. Okay, in other words, we could say, well, we already know that r is the square root of x squared plus y squared, so we could just put the square root of x squared plus y squared in there. And we know that theta is the tangent inverse of y over x, so I could just put tangent inverse y over x in for that. But that would be pretty ugly. And it turns out there's actually a much more elegant way of doing this one. We don't have a conversion for 8 cos theta, but we do have a conversion for r cos theta. We don't have anything for cos theta, but if we multiplied that by r, we do have a nice conversion for r cos theta. We know that r cos theta equals x. And so, if I multiply both sides of this original equation, if I multiply both sides of r equals negative 8 cosine theta by x, sorry, not by x, by r, then my left side becomes r squared, and my right side becomes negative 8r cosine theta. And that might not look better, but it is. Because r squared I know is x squared plus y squared, and r cos theta I know is x. And so this just becomes this. And that's actually quite a lot nicer. I can do a little bit of work. I hope that you recognize this as a circle. Okay, x squared plus y squared. So that's a circle. And if I wanted to graph it, I could put it into standard form. I could move the 8x over. I could do the completing the square, and I would get x plus 4 quantity squared here. And then I subtract 16 because I got an extra 16 in there, plus y squared equals 0. And then taking it to the other side, I get x plus 4 squared plus y squared equals 16. And I recognize that that is a circle. The radius is negative 4 comma 0. Sorry, the center is negative 4 comma 0, and the radius is 4. And so that's a somewhat nicer way of looking at that. That said, you might make the argument, and many people would make the argument, that this Cartesian form of the circle is more complicated than the original polar form. And once you work with polar curves enough, you'll start to recognize that, oh yeah, r equals negative 8 cosine theta is just a circle centered at negative 4, 0 with radius 4. There's two ways of looking at that. You haven't dealt with Cartesian equations enough yet to recognize that, but eventually you will. So that brings us to the conclusion of this second part of the lecture. For those of you in my math analysis class, there will be homework posted on my Google Classroom page, and that homework is handout page 558, and you can take a look at questions 1 to 54. You don't have to do all of those, but do selected questions from those and make sure that you're understanding it. As always, if you have any questions, send me a WhatsApp and let me know, and I hope that this made good sense. Thanks.